Hello. In this lesson, we will continue to talk about the special angles and their important role in supporting us to view the function and to see see the trig functions being applied to these special angles with special reference angle. So this one is pi over 3. This one is pi over 3. Now, according to definition, of course, we still have the definition, right? The function is a rule, right? We have 6 rules in the trig function. Of course, we have more, but for now, we're discussing these 6 rules, and we know that each one of them has angles as input, and they produce ratios of various sort, okay? For pi over 3, 60 degrees, right? For 60 degrees, I bring back the pi over 6 example because you can see as we measure these angles, right? As we measure these angles from the standard position, whether counterclockwise or clockwise or go around and round, when we terminate over on this terminal, we pick up the points arbitrarily, and we know that it would be convenient if we pick the points at the intersection between the terminal and the unit circle. So we want to determine the coordinates x, y, right? For that reason, and we're going to make this triangle. We have studied this triangle in the video about applying definition of trig functions to pi over 6 as a reference angle. So therefore, and this time the red is half, the blue is √3 over 2. Okay, so this time we don't need to do any calculation. We don't need to do any calculation. And because, we have studied this triangle, this is unilateral triangle, right? Now, the blue is √3 over 2, and the red, so this point, x comma y, and the x value is half, and the y value is √3 over 2. As a result, by definition, right? By definition, right? Sine of any angle that terminates on this terminal is going to be equals to y. Okay, and cosine would be, half. Okay. And from this point on, we can go fairly quickly, because on the second quadrant, right, if there's any terminal, any angle who terminates on the second quadrant like this, and this triangle is the same, it's the same as the other triangle. So this red is half, and the blue is √3 over 2. Red is half, blue is √3 over 2. So these points, x comma y, is going to be negative half, right? X is negative, and y is √3 over 2. Okay, so this is cosine, and that's sine. Okay, so as a result, we know that sine of any angle that terminates on that quadrant with overlapping with this terminal is going to be √3 over 2. √3 over 2, and the cosine is negative half. It's negative half. So we're very much close to complete all of these special angles, and of course we still haven't completed. Almost there. Okay, so be patient. Okay, we're almost done, but these discussions are very important because we're applying definitions. We're applying definitions. So in the third quadrant, right? In the third quadrant, the point, right? This is the red. The red is -½ The blue is -√3/3. And the sign, cosine, okay, they're both negative. They're both negative. Last but not least, terminates on the fourth quadrant, okay? Terminates on the fourth quadrant, sorry about that. So in this case, the point xy would be, the red is half, okay? And the blue is √3/2. I've been using these colors consistently, okay? I hope you guys have get familiar with them. And by this time, right? So now sine of any angle that terminates on this terminal is going to be, oh, this is going to be negative. Sorry, this is negative, right? -√3/2. And cosine of any angle that terminates on this terminal is going to be half. Okay. There. Okay. So we're going a little faster, but if you have any questions, please don't hesitate to ask me. Okay. Now, summary. Okay, so this summary is similar to what we have done before, right? So it's just one by one, we put them together very soon. Okay, hold on. I'm gonna put this on the fourth quadrant place. Okay. This terminates on the first quadrant, second quadrant. First quadrant. In that order that you're familiar with. Okay, this is just one way I wish to show you how to summarize your work. And you know, it's a way of studying, right? Summarize what we have learned. It's always a good place to have a deeper understanding of the material, to have a better familiarity with them, and to see common, you know, the common feature, and see the variations. Right. So with that said and done, and we can see these points, x comma y is equals to, now the red is half, the blue is √3/2, right? And √3/2. By this time, we should be very familiar with it. Okay, in the second quadrant, that point is -½ The third quadrant, both are negative. And the fourth quadrant, y is negative. So the blue is negative. Now, right, sine, cosine, we all find them. So sine of any angle that terminates on that terminal is going to be the y, right? And cosine is going to be 1/2, right? And now, okay, you may like to grab a piece of, you know, you should have your notebook with you. On the second quadrant, cosine is negative, sine stay the same. Okay, third quadrant, both are negative. In the last quadrant, sine is negative, cosine is positive. Okay, so now let's get ready to do some calculation. Okay, so this will be, we will need your basic skills. So we're going to do tangent and cotangent. We're going to do tangent and cotangent. I think you will need these basic skills. Okay, so for tangent, of any angle that terminates there, of course, is going to be y over x, right? Y over x, this is going to be y over x definition. X is half, right? X is half. And simplify, the answer is going to be √3. The answer is √3. Tangent of any angle in the second quadrant is still y over x, but this time we have a negative, right? So everything is about the same, except that the denominator is negative. So the rate, the quotient is going to be negative. In the third quadrant, okay, in the third quadrant, y over x, so negative over negative. So tangent of this angle is going to be √3. Last quadrant, right? Tangent of A of any angle that terminates there is going to be, there's a negative divided by positive. So right here it's going to be negative. Cotangent. Okay, so let's do a little calculation, you guys. Please get involved, okay? Cotangent is the reciprocal, right? Reciprocal, that means if tangent A is √3, cotangent A is going to be 1 over √3. So we know that if we rationalize it, right, we have done those exercises. So this is going to be √3 over 3. Okay, and all of these other situations are going to be similar. Okay, it's going to be similar, except in this interval, it's going to be negative. In the third quadrant, it's going to be positive. Okay, cosine over sine, right? In the last quadrant, it's going to be negative because we have a negative and a positive, right? So this is going to be negative. And I will leave it for you to do secant, cosecant. Okay, and the last but not least, okay, there are other special angles we haven't studied. So what are these special angles, right? Hold on. You can see that we are getting closer to have something like, to put all of these together, right? To put all of these together. Some of you probably memorize this by heart, right? So this is where we're heading. What we have been doing for reference angle 60 degrees, 30 degrees, 45 degrees, and 30 degrees, right? Pi over 3, pi over 4, pi over 3, all these cases we have studied, right? We have got the red number, blue number, red number, blue number. They are all can be found here. They can all be found here. If you put all these 3 cases we have studied, right, on the fourth quadrant, we have studied them all. Last we have not studied are the terminals overlapping with the standard position, terminal over here, terminal over there, and terminal down there. And that's what we're going to study next. Okay, that's what we're going to study next. So let's do it. Okay, I'm going to bring back our, this time we just need we don't really need all these other drawings, right? We just need, we just need to clean up a little bit. Oh, I'm going to use this one. Okay? I'm going to use this piece right here. Okay? And we're getting there. And I'm going to remove this line. Okay? I'm going to remove that line. And I'm going to change this to pink because we changed that to pink for consistency. Okay, for consistency. And I'm going to remove that line and the point. Okay, delete, there. Okay, so the point will begin concerning is I say, suppose we measure an angle, right? It could be, it terminates, the terminal overlap with the standard position. That's angle 0, right? If the angle is 0. And the other one, it could be pi over 2 or, 3 pi over 2 or pi, right? So we have some special angles about these 4 terminals. Okay, 1, 2, 3, 4. So let's see what happens if the angle terminates, okay, right here. Okay, that's the terminal. Okay, the terminal overlap with the standard position. Okay, so in that case, the point we can pick, okay, the point we can pick on the unit circle is 1, 0. 1, 0. Okay, so let's put the red dot there. Okay, whoops. How come it doesn't show the red dot? Oh, I didn't click the dot, the point. Okay, that's the point. And this point is 1, 0. Okay, this point is 1, 0. Okay, so 1, 0. 1, 0. So I'm going to put it at 1. So maybe this is 0.1. So we're going to mark that point. I'm going to mark that point. Just like that. Okay, 1, 0. Any terminal terminates on the standard position. So whatever that angle is, right? So we already have the x and y. So xy is 0. I'm sorry, is 1, 0. 1, 0. That is to say x is 1, y is 0. So let's look at the definition of these 6 trig functions. Let's look at this definition of the 6 trig functions. R equals to 1, right? So sine of that angle terminates, right? The terminal, right, is overlapping with the standard position place. Okay, it could be 0 degree, 2 pi, right? A could be, A could be 0, right? 2 pi. Wait, what did I do? Okay, sorry. A could be 0, 2 pi, right? It could be positive or negative 2 pi and so on and so forth, right? Or positive, negative 4 pi. They all terminate in the same place, right? Etc., etc., etc. So for this kind of A, sine A is going to be what? Is going to be what? It's going to be y over r. Y is 0. So 0 over r, that's equal 0. Okay. How about cosine? How about cosine? Cosine of one of these angles is going to be x over r, right? X is 1, right? 1 over r, so that's going to be equals to 1, right? Shall we make a table before we move forward? Yeah, I think we should make a table for it, right? We should make a table. There are 6 functions. There are 6 functions. Okay, so if A be one of these, right? And sine of A is going to be 0 by definition, right? So that's just 0. Cosine is going to be 1. Right? There, so we don't need that. So when this is a terminal that overlap with the standard position, right? So that's the case. Now, Over here, how about tangent? Tangent of that angle, right, is y over x, y over x, y over x. There. Y over x, that tells us that y is 0, x is 1, so it's going to be equal to 0. No problem, right? Now, maybe a few more columns. Okay, 3 more columns. Cotangent of A. Cotangent is x over y. 1 divided by 0. What's happening? Undefined. This is the play because we have a 1 over 0 case, right? 0 cannot be the denominator. Therefore, cotangent is undefined here. Okay, undefined. Undefined. So cotangent is undefined at these angles. Okay. Now, how about cosecant of A? Cosecant of A. Cosecant of A is R over Y. R is 1, right? Y is 0. So once again, it is undefined. We get a dividing by 0 case. Undefined. How about secant? Secant A. Secant is R over X, right? R over X, so equals to 1. Now, the second terminal, right? The second special terminal, which is this line, right? It could be pi over 2, right? It could be pi over 2, right? We get this angle, that's pi over 2. It could be pi over 2 plus pi over 2, pi over 2 plus 2 pi. It could go around and round, right? So in this circle, in this terminal, we have many possible angles. Okay, we have many possible angles. Let's see what are these angles could be, right? They terminate at the same place. So these angles could be pi over 2, but not limited to pi over 2, right? Not limited to pi over 2. It could be pi over 2 plus 2 pi plus 2 pi, right? It could be pi over 2. It could be pi over 2 plus 4 pi, right? So it is 2k pi. Pi over 2 plus 2k pi. K represent any integer. Oops. K represent any integer, right? In this case, right, what is the point? Okay, so let me put the point in a place, right? Insert a column. Oops. I'm going to put this over here. In the first case, the point is 1, 0. In that second position, right, the point we choose is on the terminal and the crossing with intercept, with unit circle, sorry. So 0, 1. 0, 1. Okay, so 0, 1. So in this case, sine of A is going to be equals what? Y, right, on the unit circle. Cosine of A equals what? 0. Tangent of A equals what? Tangent of A equals what? Tangent of A is equals to y over x. Y over x. We got 0 denominator. So now at this place, tangent is undefined. Undefined at these angles. Okay. How about cotangent? Cotangent of these angles, right? Cotangent of these angles. What are these angles? It's x over y. X over y is 0 over 1. So that's 0. Cosecant of this angle is 1 over y. 1 over y. 1 over y is 1, right? because y is 1. This is y is 1. Secant of these angles is going to be undefined, okay? Because it's 1 over x, x is 0, therefore this is undefined. Undefined. Now let's look at the third one. Okay, the terminal terminates on this negative direction of x-axis. Okay, so this is the terminal. And the point is -1, 0. The point is -1, 0. Okay, so this point, okay, this point is -1, 0. So please write it down. Okay, -1, 0. And I didn't write down over here. You can make it up, right? So I kind of assume you know, but I just want to make sure. Okay, so this is 0, 1. So that's the terminal, right? And we pick that point. So now we're doing the third point, and the point is -1, 0, right? So please write it down, as I'm going to have to clean it up. So on this point, what are the angles? Sorry. Okay, so it's -1, 0. That's the point on the terminal. So what are the angles that get there, right? What are the angles, right? Let's look at how we get these angles. How many angles that ends up there, right? It could be pi, right? It could be -pi, right? It could be 1 pi, 2 pi, 3 pi, right? It could be, you know, negative, positive, -3, you know, just odd number multiples of pi. Okay, so now we got it. So what are those angles? So those angles could be pi, right? Actually, it could be positive or negative pi. It could be positive or -3 pi, right? And so on and so forth, and so on and so forth. Odd number multiples of pi. Okay, and the point on the terminal is that. Okay, we don't really need these. Okay, so now let's look at sine. Sine, of course, is going to be equals to y. Y is 0. Cosine of the angle equals to what? Equals to -1. Okay, tangent of one of these angles is going to be what? Y over x. Y over x. 0 divided by -1. Okay, 0 divided by -1. 0 divided by -1, and that's going to be a 0, right? That's going to be a 0. Cotangent of one of these angles is going to be what? It's going to be what? X over y. We get 0 denominator. So once again, this is what? This is undefined. Cotangent is undefined here because we cannot have 0 in the denominator. Cosecant A, that is 1 over y. Y is 0. Therefore, this is undefined again. Now, what else? And this place, okay, this place is the last one in this row. Secant of one of these angles is going to be what? Is going to be 1 over x. X is -1, therefore this equals to -1. Okay. 1, 2, 3. So we have covered 3 terminals, special terminals, right? 1, 2, 3. This is the last one. This is the last one. This is the negative direction of y axis. So when we measure angle, it could be, of course, they all measure from standard position. 3 pi over 2, okay, 270 degree. It could be -pi over 2, right? It could be, you know, go around and round, right? Let's see, go around. We go around, adding another 2 pi to it. Okay, so there are all these possible angles that terminates here. So let's put these possible angles there. Okay, so this terminal can be angles which is negative pi over 2, right? It could be negative pi over 2. It could be 3 pi over 2. 3 pi over 2, right? What else? Well, if either one of them plus 2k pi, that's going to come back to it, right? If either one of these plus 2k pi is going to come back, right? So either direction, there are many of them where k can be any integer, So in this case, the point on that terminal intersecting with the unit circle would be this point. Okay, it would be this point. And that point is 0, comma, -1. Okay, 0, comma, -1. With that said and done, I'm going to put that point on the table, in the table. Okay, so 0, -1. So now by definition, we can do sine of A equals to y, -1, right? Cosine A would equals to 0 because x is 0, right? This is x, this is y, right? X is 0, y is -1. Tangent of A, let's see, what's tangent of A? Tangent is y divided by x, so that's undefined, right? Because we have a divided by 0, divide by 0, 0 in the denominator, undefined. Cotangent A, right? One of these angles, that's going to be what? X over y, that's going to be 0. Cosecant, that's going to be what? Cosecant is going to be what? 1 divided by y. Y is -1, so that's going to be -1. Secant of A, okay, what would that be? It's 1 over x by definition, right? R over x, R is 1, x is 0. So once again, this is undefined. So far, by this time, we have covered all the special angles. And the reason we cover these is to use definition, okay? We have also covered one example that is not a special angle, which was the very first one, okay? And I also quiz you guys about it, right? So now let's bring back our, this piece, okay? If you would take this unit circle, I got this on the internet really, okay? I did not create this one. But if you look at, now you look at each one of these numbers, you know where they came from, okay? We know where they came from. And with that knowledge, right, we understand how they came, you know, these numbers have come by. And we think of the stage set, right? The stage set, the angle measurement, reference angle, and definition. All of these combined, then we will know how to read this chart. Okay, we're going to know how to read this chart. However, reading this chart is not the goal. Our goal is really to understand. Okay, definition at the beginning, right here. Okay, so this is the important part we really need to understand. These 6 functions, each one of them is a rule, and each one of them take angles, and some of them cannot take certain angles, right? Some of them can take all the angles. And that will be our next discussion, which is on domain and range. But prior to that, I hope this will be a decent summary. Okay, so all of these included the last three, last recent episodes and lessons is to reach this point. It's reached this point to get this, get to this point. And I intentionally use red number for X, blue number for Y. Okay, so this is the unit circle. This is the unit circle. Well, until next time, thank you for watching. We have more exciting discussions to, to work with, and I appreciate your time. And I hope you have learned much in the process. And I know this process, this piece can be a little bit tedious. Some of you think you know it, okay? But I still want you guys to look at these basic from the definition, the very basic discussions, and do this and have the patience to study them. And we will be rewarded richly because of these studies. Okay, so see you next time. Bye-bye.